picture, you can see that you have different varieties of costumes that you can select for a party. You have a shirt, you have a jacket, you have two colored shorts, and then you have two sandals, and then you have a purse. So once you are getting ready, you can select any out of these, right? Anything out of this. So this selection dilemma has always been there in our day-to-day life. Whenever we find some dresses in the textile showroom, you tend to select maybe one color, maybe red, maybe white, maybe black. So this selection dilemmas are always been there with us. So what has our mathematics got to do with selections? And that is where our chapter, that is combination, comes into play. Now let's look at what is the definition of combinations. Combinations is a selection of items from a set of well-defined members without regarding the order in which they are selected. So combination means you are just selecting from a particular number. Suppose you have 10 objects in front of you. You want to take 3. So you can just take 3 from that. But there are different calculations based on that. Let's leave the calculation for the time being. So when you select 3 from those 10, that is merely selection without where the order is not at all even considered. So order is not considered there, and this process is mathematically called by the name combinations. Now, let's look at 3 numbers here, 1, 2, 3. From these 3, I want to select only 2 numbers. And in how many ways I can do this? From 1, 2, 3, I can take either 1, 2, or I can take 1, 3, or I can take 2, 3. So from the combination or from the given quantities, I am taking 1, 2, 3. So I can take in 3 ways. So when I need to select 2 numbers from the given 3, I can select that in how many ways? 3 ways. But is this kind of calculation always enough for our subject? No, we need a formula for that to make calculations very easy, right? So let's look at what is the formula for finding the total number of selections or merely combinations. So the formula is nothing but NCR. Now what is this NCR? We learned what is NPR, that is what is arrangement. Now what is this NCR? You have n objects in front of you. You need to select R objects from that. So that selection can be used for the formula NCR, which is n factorial by R factorial into n minus R the whole factorial. And always check whether n greater than R. That is the total objects in front of you. You cannot select more objects than that, right? Suppose there are 10 objects in front of you, and if I am asking you to take 12 objects from that, is it possible? No. So n should always be greater than what? R. So this is the formula, that is NCR is equal to n factorial by R factorial into n minus R the whole factorial. So in the previous case, that is from 3 numbers, when I have to select 2 numbers, what will be the formula? 3C2, because from the 3 numbers, I am selecting only 2, so 3C2. So n is the number of elements in the set, R is the number of objects to be chosen from. Now one example I'm taking here, how many ways a combination of 4 different pieces of fruits can be chosen from a set of 10. So you have 10 fruits in front of you and you have to select 4 from it. So here you can see different fruits here, that is avocados are there, bananas, apples, and then you have grapes, etc. So there are 10 fruits over here and I'm asking you to select 4 from it. So selecting of 4 can be in any way. Suppose I ask you to select 4, you might select a particular set. If I ask your friend to select another 4, he might select another set of 4 fruits from that. So the combinations or the selections will be different for each person, right? So in total, how many ways these selections are possible? That is what we are going to check here. So from the 10 fruits, if I'm asking you to select 4 fruits, that can be done using the formula what? NCR that we have just studied. So here n is how much? 10, because the total number of fruits here is 10. And R is how much? 4. The number of fruits you are selecting here is 4. So using that formula NCR, you can say it is 10C4, and that is nothing but 10 factorial by 4 factorial into 10 minus 4 the whole factorial, which is 10 factorial by 4 factorial into 6 factorial. Using the calculations and factorials that we have already studied, you will finally get the answer as how much? 210 different ways. So from 10 fruits, if you are asked to select 4 fruits, that selection process can be done in how many different ways? That can be done in 210 different ways. Okay. Now, what is the relation between permutation and combination? We studied permutation, which is nothing but arrangement. So you arrange things. And what is combination? You select things. So remember the words arrangement and selection when it comes to permutation and combination. Now, there is always a relation between these two. What will be the relation between permutation and combination? That is, what is the relation between arrangement and selection? Suppose you have a class of 40 people and I need to select 5 students from that to play basketball or any game. So I take 5 from the 40 and that is what? Selection. Now, after selecting the 5 people or the 5 students from that class, I might arrange them in different ways. That is, I might arrange them in the order of their height or maybe the strength or the agility to play the game. So these are different ways in which I might arrange these 5 people. So what is happening here is I take or I select 5 from the 40 and also I arrange them, right? Here what is happening? The permutation is happening as well as what? Selection or the combination is also happening here. So both are interrelated. Now, what is the relation? So when we see that the relation, that is, you have NPR, which can be written as NCR into R factorial, which is NPR, the total permutation will be equal to the total selection multiplied by R factorial. What is R factorial? You selected 3, but you need to arrange it. Yes. So when you arrange 3 objects, that can be done in how many ways? 3 factorial ways. So when you select R objects, it can be arranged in how many ways? R factorial ways. So NPR, the total arrangements, will be equal to the total selection multiplied by R factorial. What is the proof for that? The proof is nothing but NPR is equal to NCR into R factorial, which is a theorem that we know. And what is NCR? N factorial by R factorial into N minus R, the whole factorial. And there is a multiplication of R factorial, right? And when you cancel that, you get N factorial by N minus R, the whole factorial, which is nothing but NPR. So you get the total arrangement of R objects from the given N objects. Understood? What is the relation between permutation and combination? So the theorem stands true for this one. Now, there are certain remarks that we have to remember. That is, if R is equal to N, that is, if you are selecting all the objects, suppose there are 10 fruits in front of you, you want to select all the 10. So R is equal to N in that case. So the formula will be NCN, which is nothing but N factorial by N factorial into N minus N factorial, which is 0 factorial. And what is 0 factorial? 1. So doing all the final calculations, you will get it as 1. So when you have 10 objects in front of you, you want to select all the 10 from that. That can be possible in only how many ways? 1 way. So that is the first remark. And the next one, you have R is equal to 0. So that means you are not selecting anything from that. If you are not selecting anything from that, it is always NC 0, which is N factorial by 0 factorial into N minus 0 factorial, which is also again how much? 1. So when you are selecting all the objects from the given one, it is also 1 way. Also, when you are not selecting anything from the given objects, that is also in how many ways? 1 way only. Now, NC N minus R. What is this NC N minus R? So that is a property that we can use here. NC N minus R is what? N factorial by, when you use the formula for NCR, you will get N factorial by N minus R the whole factorial into N minus R the whole factorial, right? So when you cancel these two, you will be getting N factorial by N minus R factorial into R factorial, yes, which is nothing but NCR. So NC N minus R is also equal to NCR. So this is another important formula that you have to remember because that is useful in many of the calculations in this section. And the next one here is if NCA is equal to NCB, then from that we can conclude that what? A is equal to B. That is, to select A objects from N objects, what is the number of ways? If that is equal to the selection of B objects from N, then from these two, I can conclude that A is equal to how much? B. Or also A is equal to N minus B. That is another way of conclusion that I can get from here. So either A is equal to B, that is one conclusion. And the second conclusion is A is equal to N minus B, or I can also say N is equal to how much? A plus B. So these are the different conclusions you get from the formula of combinations that we have studied. So you have a theorem over here that is NCR plus NCR minus 1 is equal to N plus 1 CR. So very important formula that we have to use in this chapter. So if I have to find the proof for this, and if I take the LHS, that is NCR will be equal to N factorial by R factorial into N minus R the whole factorial, plus NCR minus 1 will be N factorial by R minus 1 the whole factorial into N minus R plus 1 the whole factorial. So I wrote these two as sums over here. Now when you look at the numerator, I have N factorial common, but there is nothing common in the denominator. So what I have to do is I have to apply the properties of factorials. So this R factorial can be written as R into R minus 1 the whole factorial. Fine. This n minus r plus 1 the whole factorial over here can be written as n minus r plus 1 into n minus r the whole factorial. So now I have n factorial common, yes. Then I have r minus 1 the whole factorial common, yes. Then n minus r the whole factorial also common. So I take this common outside, I'll be getting inside 1 by r plus 1 by n minus r plus 1. So doing all the calculations inside, I will be getting n factorial by r minus 1 the whole factorial into n minus r the whole factorial, which is nothing but n minus r plus 1 plus r the whole divided by r into n minus r plus 1. I can cancel all the r's, and finally I can write it as n plus 1 the whole factorial by r factorial into n plus 1 minus r the whole factorial. How did I get this n plus 1 the whole factorial? I have only n factorial in the numerator. Now look here, when you cancel this r and minus r, you have n plus 1. What is n plus 1 into n factorial? It is nothing but n plus 1 the whole factorial. That is 6 into 5 factorial also same as 6 factorial. In that same way, n plus 1 into n factorial is n plus 1 the whole factorial. So I can write it over here. And same way, I have r and r minus 1 the whole factorial. And when you take the product, you can write it as r factorial. And also you have n minus r the whole factorial and n minus r plus 1 the whole factorial, which is nothing but n plus 1 minus r the whole factorial. So in that same way, if I write this, I can conclude that as what? N plus 1 CR. You have n plus 1 in the numerator, yes. So n plus 1 CR. That is, you select R objects from the what? N plus 1 objects. So this is the proof for the theorem over here. You have to understand this theorem very carefully because it is a very important one in this chapter as well as in binomial theorem where you deal with the coefficients of expansions. So remember this formula. Now you have an example over here. If NC9 is equal to NC8, find NC17. We studied what is NCA is equal to NCB. If NCA is equal to NCB, there are two conditions. Either A is equal to B or N is equal to A plus B. So to find the solution NC9 is equal to NC8, I can go this way also, that is n factorial by 9 factorial into n minus 9 the whole factorial, which is equal to n factorial by 8 factorial into n minus 8 the whole factorial. And from this I can cancel n factorial, all these things. 9 factorial and 8 factorial gets cancelled, it will become 9. And n minus 8 and n minus 9 factorial gets cancelled, it will be n minus 8. So I'll be getting 1 by 9 is equal to 1 by n minus 8 or n minus 8 is equal to 9, which I get it as n equal to how much? 17. So now what I have found out? I have found out what is n, 17. The question is to find out what is NC17. What is NC17? It will be 17C17. I'm selecting all the 17 objects from the 17 objects, which is nothing but in how many ways? One way. So what is NC17 or 17C17? It is 1. Another example over here, a committee of 3 persons is to be formed from a group of 2 men and 4 women. In how many ways can this be done? So I need to form a committee of how many people? 3 persons from the 2 men and 3 women given there. So let's look at the solution here. I know the formula, what is NCR, n factorial by r factorial into n minus r the whole factorial. Here n is equal to 6. There are total 2 men and 4 women. So I have total 6 people there. So n is equal to how much? 6. And I have to select how many people from that 3 people. Is there any condition given there in the question? That is, I need only 1 man, I need only 2 women. Is there any condition given in the question? There are no other conditions given in the question. There is only condition given in the question is, you just have to select 3 people. It can be in any way. So what I have to just do is I have to take the total number of people over here. So 2 men and 4 women, including that, will be 6. And from that, I have to select only 3 from that. So what is 6n? What is 3? It is r. So what will be the total number of selections? It will be nothing but 6C3, which will be 6 factorial by 3 factorial into 6 minus 3 the whole factorial. And that is 6 factorial by 3 factorial into 3 factorial, which by doing the calculations, I will be getting it as how many? 20 different ways. So that is the total number of ways you can form the committee of 3 people from the given 2 men and 4 women. Listen here, there are no conditions given in the question other than selecting 3. In some questions, there will be conditions where you have to select only 1 man or maybe 2 women. So in this question, there are no conditions given there. Now let's look at another example here. A team of 5 members is to be formed from 9 boys and 4 girls. In how many ways can this be done when the team consists of 1 boy and 4 girls, 3 boys and 2 girls? A bit different from the previous question that we explained. What is the difference? There are conditions. That is, you have to select 1 boy and 4 girls in one case, Second case, you have to select 3 boys and 2 girls. There are 2 different conditions or cases. So let's look at the first case, 1 boy and 4 girls. So from the 9, from 1 boy and 4 girls, how can I select? From the 9 boys, I can select 1 boy in how many ways? 9 C1 ways, right? Yes. And 4 girls, there are total 4 girls only there. Yes. So I can select that in how many ways? 4 C4 ways. So 1 boy can be selected in 9 C1 ways. 4 girls can be selected in 4 C4 ways. I need both of them for the group also. So I have to multiply 9C1 into 4C4, and that will be 9C1 into 4C4, which is 1. So 9C1 will be 9 into 1. That gives us total how many ways? 9 ways. So 1 boy and 4 girls can be selected in how many ways here? 9 ways. So there is a condition over here, and you have to go for that condition, which is very, very important. And the second condition here is I need to select 3 boys and 2 girls. 9 boys are there. I have to select only 3. Or you have to select 3 from your 9 friends. In how many ways you do that? 9C3. 2 girls from the 4 one. That will be in how many ways? 4C2. And you need both. That is, you need both boys and girls. Look at the connecting word there, which is and. So you need them both. So when you need them both, what you have to do is you have to merely multiply it. So which is 9C3 into 4C2. And that will be 9C3 will be 9 factorial by 3 factorial into 9 minus 3 the whole factorial. Into 4C2 will be 4 factorial into 2 factorial into 4 minus 2 the whole factorial. Doing all the calculations, I will be getting it as how many? 504 ways. Always use the formulas of factorials that you have studied, right? So when you use them, you will be directly getting the answer. With the correct calculations, you will be getting it as 504 ways. So that is the number of ways I can select 3 boys and 2 girls from the total given 9 boys and 4 girls. So now we have come to a conclusion for combinations. In this section, we have discussed how to select R objects from the end given objects, and then we have studied different theorems, and then we studied different properties also. And now we are coming to a conclusion for the entire chapter, permutations and combinations also. So let's summarize it here and see you in the next session. Until then, keep exploring.
Manorama Horizon. Learning made simple.